I had to restart the stream. So, well, proceeding. Let me pause the cell phone stream. Paused. So, hi folks. Today I wanna check whether I can make a threaded matrix multiplication in CPU, copying what NumPy and BLAS do. NumPy is the Python version, BLAS is the background C++ implementation. So let's see if we can make this in high level. I want to copy this tensor here because it's easier to test everything in the same file. What did I make wrong? I'm initializing the tensor the wrong way. This way has no initialization. Great. So I checked in Colab that the matrix multiplication was okay. If it works for more than 4 rows and 8 columns, then it works for any dimension. One thing I need to check, two things I need to check is whether I didn't mess up the code for threads instance inside other functions, and if I am passing the object. If I call a finish async inside a object method, I want to check if it works as well, because I don't think I am passing the object pointer yet, but that's simple to solve. the tokenizer has a bug for the code line. We couldn't still figure it out. Okay. So the pointer is shared. Probably I have what I need to make the parallel matrix multiplication. I don't think, well, I don't have access inside threaded code for the amount of threads spawned. I have access to the thread ID, but the code itself doesn't know how much threads have been spawned, which would be useful to determine the stride to which I want to jump. This pointers here. So I'm going to I have to offset the threads, the pointer inside it, the matrices, and then I gotta, maybe it would be easier to generalize to any pointer shape first, because this only handles matrices, but in theory I could matrix multiply a 3-dimensional tensor, just matrix multiply the last 2 dimensions, and leave the other ones as batched, but I'm more curious to see whether the parallel version will work. There may be no data races because you're not sharing any store locations. Data races only will occur if there is a store with any other operation to a specific memory address, but each thread will write its own separate address. Did my live bug? The session says 000 seconds. Well, okay, just had to refresh. I will assume it's a constant for now, so it always spawns 4 threads. This thing here still doesn't. It's just a constant. It's just a compile time const. I don't know if it's really a problem. Well, I wish I could instantiate this from a global, but the threads themselves are releasing runtime. The amount of threads to be released is decided in runtime. So that's, we'll leave this as it is for now. So if this is the last thread launched, it should detect after. For now, can do a bit different. Won't need this, but I will be able to test it. We can allow threads not to process multiple columns and rows not at the same time, but only one of them. Sorry, to the wrong locations it seems. It's because one of them was 0, perhaps. But this one seems to be more correct at least. Okay. So this is probably a correct matrix multiplication, but there are all 4 threads doing the whole matrix multiplication, but I want each thread to do just a slice of it. So this is the row that I want to process. That's what I'm going to work at. It's just thinking, just wondering. Close to a CUDA kernel. Getting close to one. My trauma is gonna go back. Great. Aí tá a comma. Well, I think this was this one. Honestly, can just think about the benchmark, but don't just set it to one thread. Oh no, if I set to one thread, if I set to one thread, oh no, instead of finish a sync block, it will have to wait for the thread to finish. It will have a thread spawn offset overhead, but it doesn't matter. So now there's not a single YI instance, so I can just make that. Great. JMains should be the same. And there are other Ys here, so I'll make a macro, but I'm not still fast enough to make macros. TY, forgot to set the data type. So now I can test if it's working threaded. Very simple heuristic. So this should be the threaded version. Let me check. Let me be sure. If I set the row offset to 0, then it should complete only the first block. Yeah, this is trash memory. And this is the first 8 rows. So, yeah. I can't believe it works. Just like that. Just like that it works. This is the tail. So I don't really need to worry about it. Yeah, I don't really need to worry about it. Because I could let this portion work on for the last thread. But it will need to execute it serially anyway. The only problem is that I will have to wait until all threads to finish, but they are expected to finish how about the same time. Their timings will mostly vary because maybe one thread gets swapped by the operational system to run another thing, maybe a CPU core does that because of the scheduler. But it's probably just going to be a very small amount of time. I don't need to worry too much, so I can leave this here. And what I need to fix is this asyncs count, because probably need a global constant. This is easier to fix. Can add it to the scope struct and do the same as I did to TID. TID gets loaded on the first occurrence. It performs a pointer load from the scope struct, but later occurrences are saved. Its SSA value is saved by LLVM because it's a reused value pointer. but this thing here, the fact that I can't use a variable here for now sucks. So yeah, I will make this video short, this really short, because I think that people like not long videos, and that shows how fast I could make this, how simple it was to change serial code to threaded. But I still need to perform the benchmarks, but I will make this separately because that's gonna take the most part, and then we'll try to fix this. And today is Saturday, so maybe I just don't want to code too much. That's it. So that's it for the video. That's how easy Neve threads are.